Understanding the tangent ratio. To understand the tangent ratio, what I've done here is taken a set of triangles. These are all right triangles. What I'm trying to say is the triangle ABC is the right triangle, so this is a perpendicular. This is also perpendicular, and this is also perpendicular on line AF, right? So we have set of right triangles. As you can see, triangle ABC is similar to triangle ADE, right? Since these are right triangles and angle A is common, correct? Similarly, triangle ABC is similar to triangle AFG. So we have all these three sets of similar triangles. Now when the triangles are similar, then the ratio of their sides is always constant, correct? So we know that CB over BA will be equal to ED over DA, and that is going to be equal to GF over FA. So what I'm trying to say here is that the ratio of sides, so these are the legs of the right triangle, the ratio of the legs of the right triangle are always constant, so that will be equal to a constant. So this constant really depends on the angle A. It does not depend on the size of the triangle, right? You can increase it further, but still the ratio of these two legs of a right triangle will always be constant. So that is a very good observation. Do you see that? So this ratio is only dependent on angle A, and we call this ratio of opposite side to the adjacent side as tangent ratio. So that is how it gets its application. So this ratio is always constant and it is dependent on the angle. As you can see, GF, ED, CB are sides opposite to angle A, and FA, DA, BA are sides adjacent to angle A. Angle A making with the 90 degrees, right? So we give it a special name and we write it like this: tan of A, which is equals to opposite over adjacent in a right triangle. Right? That is important. The triangle should be a right triangle for all this, right? So that is how we define tangent of an angle. So it is a ratio of opposite side over adjacent side in a right triangle. And as you have seen, it is always constant, correct? So, and this helps us to solve many triangles. Well, you can appreciate that if I draw any triangle for that matter, let me draw a triangle here and show you what I'm trying to say. Then I can always drop a tangent. I can always drop a perpendicular. Now this perpendicular will divide the triangle into two right triangles, right? And then we can solve using tan of A, this triangle. So solving triangles means solving for their sides or for angles gave rise to a new field, which is trigonometry, and which we are going to discuss now. Okay, so we'll start with tangent. Then we'll learn what sine and cosine are, and then we'll do some more application problems, right? So remember this: first trigonometric ratio we have defined as tangent of an angle, which is equal to opposite over adjacent, and for any angle it is always constant. For any angle A, the triangle may be big or small, it doesn't really matter. And the base for that is similar triangles. Do you see? Because the triangles are similar, therefore this ratio will be constant. Right? So, the other thing is, you can find angle from here. We know this is equals to a constant, right? So, if you are given, if you can always measure these sides, so once you measure the sides, you know what that constant is. From that, we can find the angle A. How? Angle A is equals to tan inverse of this constant K. Use your calculator. Second function key with tan will give you tan inverse of that value, and you get the value of the angle. Okay, so it is very important application. In many problems to solve, you'll use tan to find the ratio of the sides, and the angle can be found with the inverse of this. Okay, so all the best, and let's look into some more examples to understand and appreciate tangent ratio. Thank you, and all the best.